All right, well, let's jump into it then. See if anybody else comes in, joins the call. So thanks everybody for coming out, and I hope that the little bit of information I've got here today is enough to get everybody sort of started on something. I didn't want to jump directly into physically building a whole lot of stuff right off the hop. So there's a little bit of theory and stuff, and a few things that kind of touch on our course material with Lighthouse to sort of get started. And then we can sort of see where we're at for time as things move along, and then we could always jump into some hands-on stuff a little bit later here. So building a home lab, welcome once again. A little bit of a disclaimer, of course, this has nothing to do with Lighthouse, so make sure it doesn't interfere with your studies with Lighthouse. That's your priorities. And part one, we'll jump right into it, understanding the basics of a home lab. I think a lot of people have the idea that you can just sort of plug in a box basically, and there's your home lab. You've got something up and running. But there's a whole lot more to it than just a plug and play type of thing. It can be a mix of hardware, a mix of software, a little bit of everything. And that's basically what we're going to touch on here today. So understanding the basics, what is a home lab? Essentially, it's a self-contained environment for learning and experimenting and testing in various fields of IT. For us, that's probably cybersecurity related. Some of you might want to get more technical and touch on networking or even some programming stuff. Typically, you'd see various computers like laptops, desktops, servers, etc., with different operating systems and specialized networking equipment like firewalls, routers, etc. Continuing on, Home Lab is going to provide that safe and flexible environment for your learning and skills development by keeping things generally isolated from an existing network, so you can simulate real-world environments and scenarios without risking any live, aka production systems. Keep that in mind, live and production, or lab and production, I should say, as we sort of move along. There's differences there, and as you work and build a home lab, it's something to sort of keep in mind and keep separate as you work along. So what we're not doing today is jumping headfirst into something complicated like actually building a server physically, and we're not going to engineer any complicated networks or anything like that. I just want you to understand a few basics and progress from there. It's sort of some stuff that I've seen a few people sort of stumble with during this course, especially into the networking section, week one, and even just the virtual machines from week one, and understanding what those virtual machines are in a lot of cases. So lab or production, like I was saying there a couple minutes ago, we want to try and keep in the back of our heads the difference between production and lab environments. Production, basically, if you've got something that works great and people are dependent on it or you're dependent on it, that's kind of your production machine. Your lab machines would sort of be something that you can destroy, not physically, but if you've got an operating system on there, you want to be able to just wipe it at any time and put something different on or manipulate it in different ways. That's not going to affect your day-to-day operations. In my case, in my example here, say you've built up a media server as part of your lab, and you've got TV shows and everything on there. The kids are busy watching their Saturday morning cartoons off of your media server, and you've allocated too much RAM to an experimental virtual machine. You crash the whole system. Now the kids are screaming at you, "Mom, what did you do?" Or "Dad, what did you do?" You know. So just keep that in mind. Maybe you've got a centralized file server that you built up from scratch going on in your house, and again, you crash it and you've got to wipe everything. Now everybody's like, where's our data gone to? So keep that in mind, production versus lab, and try and keep a separation as you get things built up and working. Allocate equipment or resources to keep things running if you've got something that you consider now production, if it's moved out of a lab setting sort of thing. Planning a home lab. Probably think that planning is pretty important. Your home lab can be simple, complicated, anything in between. It can be zero cost, it can be high cost, or of course any combination in between. That being said, I don't think planning is important in a home lab to a certain degree. It kind of takes the fun out of it, if you want to call this fun. But just experimenting and building is part of home labbing and that whole experience. Planning is for when you're engineering an IT infrastructure for a business, and it needs to be done right the first time, of course. If we're playing around and experimenting, obviously don't waste money on equipment that you don't need. Buy intelligently, buy from knowledge and research. So where I started, I'll just touch a little bit on some history here. It kind of shows the progression of home labbing. So back in the 80s, Commodore VIC-20 stuff with tape drives for storage. Into the 90s with DOS-based PCs with 8-inch floppy disk. And I'm sure a lot of you probably don't even know what floppy disks are nowadays. Doing something called BBSing. This is called bulletin board system. I had a 3-line dial-up system, and I had to have 3 computers, basically one for each phone line that came into them. And so 3 people could connect to what people would call nowadays as a website, to communicate with each other, send mail back and forth, communicate on public forums, all that kind of stuff. And somebody would disconnect from a phone line. It would be free for the next person to call into. So those 3 computers were all networked together. A big deal back in the day when a computer was the size of your kitchen table almost. But it was a lot of fun, a lot of interesting stuff going on there. I was kind of an electronics nerd as well. I got into stuff like phone phreaking. I could go up to a payphone, run a gadget that I made, get quarters out of the machine, out of the phone, take it to the arcade and play video games. Again, probably a lot of you don't even know what arcades are anymore. Copy protection cracking. So back in the Commodore days, video games in on floppy disks or tape drives, they were a lot of times copy protected. So I'd get into the back-end engine and sort of break those mechanisms of copy protection so you could send them to your friends. Not that you were obviously supposed to, hence the reason for the copy protection, but we're beyond the statute of limitations for anything like that right now. So I'm all good telling you about that stuff. From there, progressed into software development, DOS stuff. That's all basically text on your screen instead of the graphics that you see with Windows and Mac OS nowadays. Early mobile devices, the early Blackberries, and Pocket digital organizers. My current lab, if you want to call it this, at a glance. So I've got 2 places. Right now, as I'm talking to you, I'm in Amherstburg. I've got property in Calgary. So starting with where I am right now, I've got a mini PC, 48 gigs of RAM in it, 6.5 terabyte of storage, all on SSDs. And it functions as a file and virtual machine server for where I'm at. But at the same time, it links back to Calgary through a dedicated VPN and syncs up with a Synology brand network attached storage device. So it's got 12 drive bays in it, functions as a file and a media server to myself, family, and I've got some clients that are actually on it as well for business use. Raspberry Pi digital display server. So it reads off of my server some data and pulls up different displays. I think Mr. Franks might have talked one day about magic mirrors, and that's the same idea. It just doesn't go through a mirror to look at yourself in. It's just an information board, typically what you'd see in like an airport. The different arrivals and departure times and weather and time and all this kind of stuff. Reason I've got that is because I've actually sold the software that I wrote to do this through to a couple of companies, and they run these in their businesses. So I have to keep an eye on how the software is functioning and any updates that I do to the software, make sure it behaves, of course, before pushing out updates to the clients and having their systems crash. Of course, I got multiple laptops. I got a Mac that I'm sitting on right now. I've got a Windows machine sitting to the side of me. The one back here is a Windows machine. I got 6 Lenovo's sitting under my desk, still in a box. I got a brand new Microsoft Snapdragon machine sitting right beside me too. I guess you guys can't see it from there. All kinds of gadgets, too many gadgets. ISP only router. I got a switch to manage all the stuff that gets hardwired, even though there's really nothing at the moment. And I mentioned the VPN back to Calgary. So if we scoot over to Calgary, like I said, the Synology NAS, that's a brand name box. You essentially buy it, put some drives in it, plug it into your network, do a little bit of configuring, and all of a sudden you've got a file server. The things work great. I've also got an Unraid system. This is a brand of software. It's a server operating system. 14 bays, and when I say bays, that's for individual drives. So I got 14 of those full, so it functions as a file and a virtual machine server. The VLAN has multiple machines that typically run and do different tasks, and that's why they're in a virtual machine. I want to keep those tasks separate, so nothing conflicts with one another. I got another Unraid system. This one's 17 drive bays, and it runs as backup file server. It collects everything from the Synology, everything important from the Synology and this Unraid system, and keeps it backed up. Another digital display server, of course, more gadgets, several switches to connect everything across my place there. Wireless access points, that's what WAP is, across multiple rooms, of course. Dedicated router with firewall rules, and that functions as segregation of IoT devices and security devices. And then, of course, an ISP router. ISP router on both sides here, of course. When I say ISP, that's our internet service provider. Where I am in Amherstburg, that's Bell. In Calgary, I've got TELUS. Not that that's really important. So just continuing on a little bit more here. Like I mentioned, Synology brand NAS here, but that started before I got into this thing, was just a single external disk. And a lot of you have them. This one here is an SSD, so it's very tiny, just a ½ inch or so thick and a couple inches square. 2 terabytes of storage on this. But where my lab started was a spinning disk, the bigger 3.5 inch style with an external power supply. I plugged that into the ISP's router just to have centralized storage. Second drive, I then had on a local laptop just to back that up. That migrated then into this Synology, because the Synology does something called RAID with its storage. So part of your homework assignments that I've got in here, although maybe you didn't expect I'd have homework for you, is to understand what RAID is. But basically it's a redundancy system. Sometimes, not always. You can have RAID as what's called JBOD, which is just a bunch of disks. So in this case, we've got 4 bays pictured, and we could have 10 terabytes in each, which would be 40 terabytes in total. There's different RAID levels, so you could have 4 disks of 10 terabytes each, which in certain RAID levels, they basically mirror their data onto one another. So you could have 20 terabytes out of the 4 disks, because 2 of the disks are used to sort of mirror and replicate that data. So then 2 disks could fail and the other 2 would keep running. So you basically never lose anything unless your entire system goes down. So just keep that in mind. You might want to look up some more about RAID and what that does. So like I say, migrated into this thing. It started doing double duty as a file server for the home, plus a media server for the home. And if you remember back just a few minutes ago, I was talking about lab versus production. So all of a sudden now, because this thing's doing a file server for the home and a media server, that kind of comes out of the Homelab. Even though I have it listed as a Homelab device, I sort of start considering that a production level device, because I don't want to play around too much with it, break it, and then all of a sudden I lose my file storage.
So I have a quick question.
Yep.
And I don't want to sound like this is going to sound really green. So basically what that is it's a place for you to store everything, but also does it make your network faster? Because everybody's got their own place to run their stuff off of? Is that what that is? But you're still on one IP, right? Like you still have your host, you're purchasing your internet service from your provider.
Correct.
So but you're having different servers in the house. for different things. Does that help you run your network faster at your home network?
No, it won't run any of the network itself faster. It's just centralized. The bulk of this device is around storage. It's a file server. So it's centralizing the storage location. So in a way, you could think of it faster, because if you had a set of files that you yourself were working on and you wanted your husband to work on them on a different computer, um, without something like this, you're probably copying them onto a USB stick or the external drive,
Right.
like I showed you, taking them physically to the other computer, plugging it in, copying them, or working right off the drive. So something like this, you're working directly off of this drive
Right.
um,
Okay.
instead. So in that case, it's faster, but as far as the computer speeds themselves, you won't get anything faster.
No.
No.
Okay, now I get that. And the other
Okay.
thing too is also it's backup. Like it's a place that will safely store all your stuff so that if something does crash or whatever, then you've got.
Yeah, yeah. You could certainly not even use this thing as central storage for everybody. You could have your computer backing up to this, constantly, or once a day or a couple times a day, whatever you wanted, and everybody else in the household backing up to that device. And then yes, that would be a backup device at that point.
Okay, thank you. That just helped.
Okay. Now, that all being said, too, this thing can do a whole lot more than just serve files. Like I mentioned, media server, you can actually run VMs on here a little bit slowly, so I don't recommend it, but it does do a lot of stuff. User management, the whole thing. So it is quite versatile. So that
To
thing,
ask you, Ernie,
yep,
regarding that box, um, you see how different types of storage devices or like different types of storage can do different things.
yes,
Like when it comes to the spinning disk, right?
yeah,
They say it's recommended not to consistently be reading and writing, right? So if
hmm
you use it like a server and there's consistently traffic going in and out, and it's reading and writing, reading and writing, the longevity of that and the chances of something going wrong is going to be a lot higher compared to like an M2 card, right? Because it's more of a what's the
um,
M2 card? It's
it's
SSD type memory.
yeah. So it honestly kind of depends on how things are set up. Like I've got spinning hard drives that have been running for years flawlessly.
Problem.
I've got ones that are practically out of the box, and a few days later they crash. Though they're mechanical devices, they're electronic and mechanical. Stuff can and will go wrong. Um,
Okay.
in theory, because your hard drive, is
Malleable.
um, well, I mean, they do everything kind of has that mean time between failure sort of thing. So it's kind of a hard thing to describe. Um, but
Between hard drives and SSDs, though, there's a big gap, correct?
there is, but sort of where I'm going is it also depends on configuration, because if we stick in an SSD or an NVMe type drive, the solid state drives into a NAS, most NAS devices aren't really made. There's exceptions, and they're starting to come out. Um, they're not really made to function properly on those solid state drives, so they actually wear out the drives quicker than a spinning hard drive.
Gotcha,
But there is a couple of products on the market for doing just solid state file
gotcha. Okay, we're
servers.
just like heading in that direction now. Okay,
Yeah. Yeah.
gotcha.
All right. So that thing, like I say, became a server not just for my home, family, and I'll touch on it in a second. Clients as well. I rent out space on it. Um, but just progressing Homelabs stuff. Once that thing sort of became production level, I ended up with a desktop tower, stuck several drives in there, and this was the Unraid I was talking about. Um, it's basically a file share virtual machine server. Stuck in more drives as I needed than a graphics card, and this Unraid operating system um, lets me create virtual machines in there as well. It's not just a file server. One of those was a Windows one, and you can pass through the hardware into your virtual machine. So I was able to plug this graphics card in, pass it through to a Windows virtual machine, and have what they call a bare metal experience, and use that as a gaming machine and a local workstation. Uh, Added a second tower because all of a sudden now I've got all this important data everywhere. Added another tower, again with the Unraid operating system, a whole bunch more disks, started backing stuff up. More parts of the home lab here. This kind of goes into better Wi-Fi, so adding wireless access points through the house, all hardwired in. And I ended up with 4 Wi-Fi networks in my house, plus Ethernet all over the place, and 4 different Wi-Fi networks just to sort of keep the segregation going on that isolates IoT devices, security devices, home lab stuff, and production stuff. So if you remember back to our networking days, we talked a lot about virtual LANs and segregation and stuff like that with our different IP subnets. So here I just talked briefly about how I picked up a client for some custom software development and rented out space on my Synology. So I got multiple clients doing that right now. Dedicated VPNs that let them all connect basically real time. They're dedicated connections that they sit on all day, every day basically, and run data there. And like I say, production versus lab. So definitely the Synology has transitioned beyond a lab device and well into production. So I don't want to experiment. I don't put virtual machines on there or a whole bunch of extra software just to test out, because I don't want to crash it obviously on everybody that's using it. Moved across Canada for a temporary time here. So I've got a small now remote lab here in Ontario that I talked about. Local file on virtual machines, nothing too exciting going on there. But it mirrors back to Calgary. So anything I do on the local server is always on the mirror back in Calgary. If I go back to Calgary and work on it there, it mirrors back to Ontario here. Dedicated VPN between the two, and it's just nice to have the local storage. If there's any network issues, I don't have to worry about that basically. The primary point of all this, though, is, as you can see, you can build your home lab as needed. I don't want to give you a parts list of everything that I've got. You run out and buy it, plug it in, and say you're good to go. Now you've got a home lab. It's all about what you want to build, what you want to do, and where you want to take it. Definitely not an all-at-once endeavor, no matter where you're starting out or where you think you might end up being. It's a lab. It's an experiment, basically. So, minimum requirements, however, to start your own lab. Basically, you just need a computer. You've already got one, and it works. Otherwise, you wouldn't be here right now. If you've got one tucked away in storage, even better, because now you got something that if you break, it's not a big deal because you're obviously not using it right now. Our primary goal, again, I just want to keep reiterating on this, develop an understanding of what you have and the direction you want to take with the lab. Like I say, it's not about building a box, plugging it in, and you're all done for the day. It's learning what you've got and building as you go. Of course, we're going to talk a lot about virtual home labs and virtualizing, but there's of course benefits to physical devices as well, although it can be more of a headache sometimes and it seems worth there's a few days you seem to think all the hardware is working together and breaking all at the same point, but it is what it is. So let's get into some hardware here. We'll talk briefly about different things. A lot of people, again, if they start talking about home lab, a lot of people all of a sudden go to servers. They think a big server rack with everything connected and a server doing whatever it needs to do. And that's fine. It is likely to be the core of your home lab, but of course, depending on what you want out of a home lab. Routers, you've already got one, otherwise you wouldn't have internet. That being said, a lot of people don't know much about their router. Do you know the IP, for example? Have you ever logged into it? Have you ever explored the benefits of what's going on in your router other than what your ISP has supplied? Have you customized it with firewall options? check the logs, all that kind of fun stuff. A lot of people haven't, and we'll touch on that in a minute. Switches. Your router probably has a built-in switch, room for 3 or 4 different devices to physically plug in. Otherwise, most people are probably running off Wi-Fi. Switches let you add physical wired devices to connect them all to your router. So if you had 10 hardwired devices, but your router only has 4 ports, you plug a switch into one of those ports, and now you've got a few extra ports you can plug other devices into. And it's generally as simple as that with what's called an unmanaged switch. Managed ones let you further configure and play and direct traffic around and things like that. We touched briefly, I believe, back in our week 1 of networking on some switches with unmanaged and managed types, but definitely not into much detail. For a home lab, depending on your budget, if you want to get into managed switches, that's great. There are virtual ones, though, that you can play with and experiment with at no cost. Otherwise, you're looking at $200 or $300 for a good managed switch, whereas $20 or $30 will get you an unmanaged switch just to keep things running. Cabling, obviously, if we're going to start connecting a bunch of stuff with cables, we need cables. Bonus points if you do it yourself with cables. You can buy bulk cable in a box and crimp on ends, and that's lots of fun, threading the connectors into the ends and crimping them together and wiring them wrong and trying to figure out which one you wired wrong and all that stuff, especially if you're fishing them through walls and all of a sudden they don't work afterwards. Finally, workstations. These are the computers like the one you're on right now, attached to your network, whether that's considered your home network or your home lab network. Whatever we want to talk about, that's what you're on right now, is your workstation. And again, we can have virtual workstations or we can have physical workstations, depending on your budget and how crazy you want to get. So working back through the list, we'll just touch on a few details. Unless there's any questions so far. All right, so working back on the list here, workstations. As a lot of you are finding out with Lighthouse right now, because of how they've got our virtual machines, we're self-hosting those on our own workstations, our own computers. A lot of you are finding they're not quite robust enough to perform well with multiple virtual machines all running at the same time, plus the host. So what I would recommend, if anybody's buying new computers at some point, some of you maybe already have, some of you are considering it, or some of you are just looking into what you might be better having for cybersecurity. So what I recommend, at least 512 gigabytes of SSD storage. There's not too much that still runs hard drive storage right out of the box. So you definitely want SSD storage for speed. SSD is solid state device. If you don't know, HDD is hard disk drive. And hard disk drives are a spinning mechanical device. SSDs are all electronic based. So ideally 1 terabyte of storage if you can afford it. Macs obviously charge a little bit more for storage than other machines. You can also do external storage, that works well as well. As you work and experiment with virtual machines, you use a lot of space quickly. So if you're not doing virtual machine work, not a big deal. 512 is fine. If you're doing a lot of virtual machines, you want to get a little bit more. RAM, 16 gigs is a minimum nowadays. Don't let Apple fool you saying 8 gigs is like Windows 16. It's not. Even 8 gigs on a Mac is I don't think they should be selling 8 gigs on a Mac if you were to ask me. So 16 gigabytes is a minimum no matter what your operating system is. 32 gigs is better. Processor, well, just about anything on the market is good. Intel, Ryzen, for Windows or Linux machines, or your M series for MacBooks. I would frown upon getting an older MacBook that has an Intel processor. Operating system, Windows, Mac, or Linux, but I've got a big but in here. And that big but is when you're choosing an operating system, and it actually comes down to more likely the processor, you need to choose based on your needs. Just like I was saying, if you're doing a lot of VM work, you want to consider that. If you're doing some programming, consider that. If you're going to sit and play games all day, you got to consider that as well. So with Lighthouse, many of us are noticing that Mac OS is not very well supported. So there's multiple reasons for that. I won't get into some of the Lighthouse specific reasons that we kind of come across. But one of the primary ones is that Mac with an M-type processor, and that's probably what most of us have, is not very well supported with virtualization software. We do have our VMware, and it works, but it's a little flaky. That's also my guess as to why we don't have the Windows Server VM. Some of you have seen in the Lighthouse material, it talks about a Windows Server, and we don't have that on our virtual machines. And like I say, I have a hunch that's because it's not supported on virtualization for the M-type processors right now. They just came out with the ARM-based version within the last 2 or 3 months, I think it was. So that's probably why it's been dropped from our virtual machines on Lighthouse. Like I said, VMware works, but many of the images you might want to use just don't work well or at all. The hardware translation in VMware just isn't there yet. I know our M series Macs have been out for a few years, and I'd like to think they would have been caught up by now, but they're not. Don't think it's just a Mac problem, and run out and buy a Windows machine either, because Windows devices with Snapdragon processors, I've got one here, it's plugged in, so I can't really go too far with it. Brand new shiny Microsoft Surface laptop, not quite top of the line, but fairly good one. It will not run virtual machines at all right now. It's a Snapdragon processor, and VMware and VirtualBox just won't even install and run, let alone any virtual machines on there. So as nice as that machine is, completely useless for virtual machines. Continuing on into our workstations, something else I see a lot of with a lot of everybody basically, not just people on the course, but everybody. I've got 2 machines sitting down here that I need to do a repair on, more or less, just because people are running out of drive space. As simple as it sounds, a lot of people just don't understand the machines. They're not paying attention to how much drive space is on them. So when you get a machine and you got 512 gigs of storage, or maybe 256, or no matter what it is, just keep an eye, learn how to monitor that. If your machine starts slowing down, try and figure out why. Is it out of drive space? Is there a bunch of stuff running? So we want to look at things like Task Manager or your Activity Monitor, and see what's all running for processes going on here. I hope everybody can see my cursor as I move around.
No, it's not visible.
Oh, let me see if I can fix that here. Show my pointer. I might not be able to.
So while you're doing that, can I just ask a quick question?
For sure.
Because I know you're saying the processor is really important, and probably, would you say the most important? Because right now you can get some really good deals, but they're kind of like on Intel, but they're i5s.
Mm-hmm.
And I mean, they're up to like an i9 now, but I'm thinking if you have like 32 gigabytes of RAM, and say you have really good 512, like you get a SSD, like you were saying.
Yeah.
And it's an i5 or an i3. Is that not worth it even looking at it?
I would probably stay away from the 3, probably no less than a 5.
5, and if you can, maybe a 7 would even be
Yeah,
better.
yeah.
Because the cost is really the difference. I mean, just, to buy like a laptop even, you can save like $300 or $400 right now on Amazon.
Yeah,
if you go with an i5.
Yeah. I would stay away from the 3, 5 probably at a minimum. The more the better, but it comes down to what we're doing. I know for us in the program right now, we're working with virtual machines, and potentially usually at least 1 running at a time, if not 2. Sometimes we need the 2 running at a time, and you can get by with that. If you start running 3 or more at a time, it's just sapping all those resources from the host.
So that processor's important too then.
Yeah, everything kind of plays in line, and everything's important in its own way. If we were to set up a virtual machine, I can assign different amounts of processors to it. So if I've got a processor that's got 10 cores for a round number, and I want a virtual machine, our Kali virtual machine, to have 2 of them, now there's 8 left. If I want my Windows machine to be a little bit more performative, I give it 8 gigs of RAM, and I want 4 cores for it. It's, there's 6 out of the 10 being used for dedicated virtual machines. So it's easy to chew up resources in a virtual machine environment. And that's important for what we're doing right now. I know, Kat, with you keep expressing the interest in forensics. That'll be very important for you, unless, of course, you're working on company supplied equipment. But if you're a hobbyist and learning, you want processors with cores, you want RAM, you want drive space. You want basically a bit of everything.
All right, that sounds good.
So, and like I say, the main point of this one here is learn how, though, your operating system is functioning, because again, a lot of people will run a drive on their main machine out of space. I'm guilty of this. When we first got our virtual machines, I downloaded everything, started installing them, because I'm used to having a fair bit of space free. And all of a sudden, these images downloading, 40, 50 gigabytes, and copy them in, and then all of a sudden my space is gone. I'm like, what is going on here? And I just got so complacent with not looking at it, because I've always had, 100 gigs or more free on any given day. It was like, what's going on? So learn just how to use those and be aware of what's going on. This screen, the one in the screenshot in the lower right, is from a Linux system, and shows me what the memory's doing, the disks are all doing, what all the processes are doing. And in the top panel, it kind of shows the processor usage. So there's different tools and different things you can do just to keep an eye on that and understand your computer. That'll be very important as you work on your Homelabs. So some more homework. I'll try and summarize this at the end, but just get to know your current workstation, how much RAM you've got in it, how much your storage space you have when you bought the thing, how much storage space is now free. Do you have solid state drive? Do you have hard disk storage in there? Solid state, again, being the faster, hard disk being slower, and typically older if you've got a laptop. And know your file system. Know how to, when I say know your file system, know how to navigate it. If you're a Mac user and you're not familiar with Windows, play around with those Windows machines. Open up that file browser in there, and just go different places off of your C drive into Windows and the user directories and all that stuff. Don't delete anything that you don't know. Basically, don't delete anything, but play around in it and just get used to navigating it. That'll help you out in week 10 forensics program there. Not to spoil it, but I was relatively easily able to find certain things in there because I know the Windows file system quite well. So anybody with a Mac, you might not know certain things, and then you're going to be left Googling and searching and asking for help on where, if you know a little bit about the file system, you can sort of fumble your way through. Jumping into cabling. You might think it's not a big deal, but we're building a home lab, and this is part of experimenting. Plus, Mr. Franks there, he often recommends your networking course to go along with your Security Plus course. I couldn't possibly tell you if these are questions on it. They probably would be. It would make sense for them to be. But just learn a little bit about different cabling types. So if you're at home and you're building a home lab and you're now connecting computer A into your router or a server into your router, because you don't want a server running off of Wi-Fi, typically. Learn a little bit about cables. For most of you, though, in a home environment, Cat5 E or Cat6 cable is more than sufficient. Our 1 gigabits per second is just data transfer rates, and you can have 100 meters max length of cable typically before you have to start running boosters in between. little bit more homework, research about PoE. That would probably be a networking question, and just understand this GBPS, gigabits per second. Switches, pretty simple unless you get into managed switches, but they connect multiple devices within a local area network by your different Ethernet cables. They communicate with each other, just forwarding data to correct destinations. Your router, like I said earlier, if it's got ports on there, it's basically a built-in switch as well. But if you run out of ports on your router, you plug one of these switches into, and then you've got, in this case, you've got several banks worth of switches there, even though ChatGPT is doing some funky stuff with some cables here, I see. Routers. I want to kind of consider this one of your most important pieces of your home lab. It's probably very much overlooked by most everybody. Your ISP came in, plugged in your router, did any connections outside, gave you an SSID, which is your like your Wi-Fi address. Of, you know, in my case, I've still got my TELUS provided one, which is TELUS 3407. You know, you might have Bell 7312 or who knows what. So your router, again, being a pretty important piece, and most people don't think anything more of it other than what's been plugged in by your provider. You pay your monthly bill and you call it a day. You come home from the store with a new iPhone or a Samsung tablet, you plug in your SSID and your password, and there's a new device on your network, and it's all good. Nobody really thinks much about it. So I want you to know and learn a little bit about your router. Do you know how to access it? I'm not sure if anybody wants to pop into chat if you've ever been into your router and you know what the IP address is to get into it. I don't need to know that, but if you've been into your router and you know how to see what's connected, that's great. But that's something I want you to learn a little bit about. If you don't know how to get in there, definitely learn how to get in there. Know what your administrator username and password is to get in there. And I'll touch a little bit more in a second. So this here is a screenshot off of my Bell router, the Bell supplied one. You can get third-party routers and use them just as well, but you would typically still need your ISP provided one just to act as an interface. So mine sits at this IP address right here, 192.168.2.1. And if you type that into your browser in my house here, connected to my Wi-Fi or plugged in, this is the screen you would see. Obviously, we're cybersecurity students, so we want to look at a few different things. Make sure you've got a non-generic password in there. Most things are pretty good nowadays, but you used to be at a point where you got these devices and your password was, or your login was admin, and your password might also be admin. And obviously not very secure, because I could pull up in front of your house, take a look at your network, and okay, well, here's a generic router. Plug that IP address in and lock you out of everything. Pretty much as simple as that back in some of the early days. And a lot of times, depending on the ISPs, it was even easier than that. Connected devices, this is just a screen. Shows our different devices on here with a MAC address. They're connected in this case. They're all Wi-Fi, different speed of the networks, 6 gigahertz, 5, 2.4. Their IP addresses that they've been assigned. And again, the MAC address is here. And then you can go into edit for different settings. I can disconnect, forget them, show disconnected devices. So if we go into settings, again, this is on Bell. Most of them are fairly simple or fairly similar. You can give them a more human name if you want. If it only comes up with the MAC address, you can tell it what it is, give it a little picture. And then you can get into stuff about your IP type, reserved or dynamic in this case. It could also say static or dynamic, and it lets you fiddle with the IP addresses. This is something important when we get into working with servers, and we'll touch on that in a couple or so slides later, or one slide later. Routers, so static IP addressing. Static IP address, are important. They stay consistent to the device that they're assigned to. So in the case of a server, we might want to access that server manually. If we've got a web server on it, we go to the IP address in the browser. If we've got files on it, we might be calling that up in the in our file manager. What is it on Mac? Finder, or File Manager on Windows. You might type that IP address in there and go to your files on there. It's a constant, non-changing address. Whereas if you have dynamic IP addressing, those IP addresses might change if the router gets rebooted, you lose power and it resets, your computer is off, then back on, that IP address might change as well. So a static IP address on a server, quite helpful. That way you always know where it's going to be, no matter what. Moving on, staying in routers though, we're cybersecurity students. We've talked about logs. Your router has a log. In this case here, I've just shown you a screenshot out of a few days ago. And by now, I think most of us should be able to look at this, although there's only a few entries in here, and say, okay, well, what might be suspicious in there? We should have that sort of sense about us and be able to look in here and say, okay, was somebody trying to hack my house here? Like, what's going on July 31st? At 9:58 and 50 seconds, there's been 1, 2, 3, 4 attempts, all with the same device, trying to connect, but incorrect login information going in there. So that should sort of raise some alarm bells, and that's one reason I want you to get into your routers, see what's going on in there and what you can find. Because what happened here? I don't know. Do I know what this device was? Yes, I do. But if you're sitting there at home and you look at your log file, it's like, okay, well, what's going on? Is my neighbor trying to hack me? Is that car that pulled up out front trying to get into my network? And they've gotten to a point where they're trying to connect to my Wi-Fi here. So it's important to know what's going on here. Like I say, we've looked at log files on our virtual machines, so that can easily translate into any device that's connected to your network here. Your router being that main point between the outside internet, the outside world, and your home lab, whether that's a single computer, a server, or a dozen different pieces of equipment. So again, that's some homework. Get into your log files on your router and see what might be going on. You might be surprised. Hopefully not, but you might be surprised. Asset management. Our Lighthouse Lab lectures talked about asset management. So knowing what's on your network kind of plays back into that log file. If I had a list of my devices with their MAC addresses, which I do, I can quickly see what that was, if it was of concern or not. To make sure it's one of my devices trying to get in and not the neighbor trying to hack my Wi-Fi, for example. So again, the homework: check your router, get access into there, see if you can administer your router. Don't play with any settings unless you know exactly what you're doing, but even then, just it works, don't touch it. But get in there with the administrator username and password. Just see what's connected to your network. If you're bored, create a topology diagram. But at least sort of have an inventory list of your devices and what's connected, just to make sure everything matches up. Unless, of course, you've given your neighbor Wi-Fi access and you don't know what all they're running on there. But just good information to know, good practice for us as students. Project. Create a simple NAS. A lot of routers let you, or have a USB port. And with that USB port, you can take your external drive, you can plug it in there, and all of a sudden now you have another piece of your Homelab, a network attached storage. So you can plug that in there and see if your router allows for it, for one, and then how would you access that. So if I took this as it is right now, I go down to my router, I plug it in, I can actually go to, in my Finder, or my Mac Finder, I can go to 192.168.2.1 through Finder, and I've actually got all my files right there that are on this drive. So now you've got a NAS drive without actually spending any more money to buy any gadgets, a Synology, or anything like that. So give that a try if you've got a USB drive kicking around. It can be a solid state drive. It can be a spinning hard disk. It can be one that needs the extra power as well. Doesn't matter. See if it'll work on your router and if you can access your files from different computers, smart TV, gaming boxes, whatever. See if you can access it and just play around like that. And like I said, that's a first great little project. You're not building anything. You're just creating a simple network attached storage device.
Hey Ernie,
Yep.
just to ask, is that why sometimes, like when you're searching through different devices connected to the router, it says it reads it as a medium-based server? Is that what it's seeing? Just there's no storage capacity, right?
Yeah, it could very well be seeing exactly that. Yep.
Okay, so we just have to attach a hard drive to it. Okay, so thank you.
You may even be able to plug just a USB stick into these things, and if you've got pictures on there, pictures are a good option. What's that, sorry?
I have the Bell router, the
Yep.
big white one.
Yep.
So,
Yep.
I'm gonna try that today.
Yep. So like I say, very simple project, and like I say, whether your USB drive or a little thumb drive, it should read it, and you should be able to see it from the computer you're on or any other computers in the house, smart TVs, all that kind of fun stuff should be able to access it. So moving on, probably what most people are here for is servers. So what is a server? Simply a computer that provides some data, resources, or other services to the other devices that are on your network. Examples, website servers. Kat, you were talking about that initially. We've touched on file servers, media servers, database servers, email, virtual machine servers, game servers, home automation, print servers, all kinds of stuff that you can do with a server. A server does not need to be a big box that's heating your home. It can be pretty simple stuff. Benefits of a dedicated server. We talk about virtualizing, so that's great if you're on a budget and you want to just play with servers. Create a virtual machine and have it do something, whether it's a file server, print server, who knows what. But virtualizing works well, but it has its limitations. So if you've got a dedicated server, it's going to be always on and functioning for you. You might want to consider, depending on how you set it up, you could consider parting ways with iCloud or Google Cloud, Netflix, all that kind of fun stuff, depending on what, of course, you set up on your server. And then, of course, that also starts crossing that line between lab and production type environments. So know what you're getting into. If you get rid of iCloud and you're backing all your photos up to your home server all of a sudden, make sure you've got actual backups that extend beyond that, because if that home server crashes, the disk that it's on, then you lose everything. Whereas with iCloud, you would still have it. So let's just say on my servers, even though I've got multiple things backing up, I still use iCloud and Google Cloud and stuff like that. I have been able to get rid of things like Netflix, though, through my media server. Again, benefits, centralizes services within your own network for whole home and family sharing. So there's definite benefits to that. Oops.
Can you explain that real quick? What did you mean by you got rid of Netflix?
Basically, I don't need Netflix or Disney Plus or any of those services anymore. I have a media server that
Stores all your videos?
it stores all my videos. All of my backed up DVDs and Blu-ray discs are on a machine, and I just play those through all my smart TVs or the computer or a tablet or the phone. So
Wait. So you have your Blu-rays backed up. The amount of storage, how big is your, like, what's the capacity? Or what do you like?
well, I don't have the full discs necessarily backed up in their raw format. They would be compressed formats. So A movie might be, 10 gigabytes. Am I thinking about that right? To still have a really good high quality 4K movie. I'm old, so I got a lot of older shows, so they take a whole lot less space because they're not 4K type videos. But I do have, like, ultimately when it's all said and done, I've probably got 3, 4, maybe 450 to 500 terabytes of storage all going on. So I do have a fair bit. But again, it grows over time, as I need it. So it's not like I would say go out and buy 500 terabytes of drives all at once and plug them in and then have them sit empty for weeks, months, whatever. So
Throughout the years, you just start compiling piles. I have like 8 hard drives somewhere.
yeah,
3 different towers somewhere.
yeah, exactly. So yeah, that's what I've done to get rid of things like Netflix. So I say backing up in quotes too, so I'm sure some of you understand what's going on there. So pre-built servers, we talked about the Synology briefly. They are great. Buy it, plug it in, do a few minor configurations, and you're all done. Get a little bit of stability and a really great experience right out of the box, but you're not learning as if you were to install, configure, and set up yourself. You'll still learn something, but if you want to learn some more enterprise stuff, you want to sort of experiment with things like Windows Server to get some Active Directory experience. Synology does have enterprise grade material and it's the same operating system, but most companies are using things like Windows Server and Active Directory on there. So we'll talk a bit more about that a little bit further down the road. But like I say, these things work great out of the box, just not great for virtual machines. More hardware options. So like I said, you can have big boxes, rack mount systems, desktop type computers to plug a bunch of drives into. You can have a laptop running as a server. You can have a mini PC running as a server. Those things fit in the palm of your hand. You have Raspberry Pis, like I showed on screen there the other day. Pretty tiny, single board computer is what it is. Everything's all on one board for the most part. And those will work for a server as well. But there's a but that comes into play with all that, of course, and that depends on what you're doing. So ChatGPT's poor design of a desktop or a tower, I guess, with a few bays in there versus a Raspberry Pi. So the big but comes in line here of what we're doing. So what I would recommend for a server, if you want to build one and put it on your network in a home lab, basically buy as much RAM as you can. 16 gigs as a minimum, same as your laptop. 32 gigs is preferred, but if you've got the budget and the space, 64 gigs. Drive space, well, as much as you can afford. Use your solid state drives for your operating system, spinning disks for bulk storage. Processor, get a Ryzen 9 or your i9 or whatever it is. Just go crazy with it, basically, as much as you can afford and as much as you can fit in your house. Or you can get a 1 gigahertz, 2 gigabytes of RAM, 4 gigabytes of storage type thing like a Pi. That's the but. It depends on exactly what you're doing. What are you going to run for services? Are you going to host a website on it? Are you going to run a file server on it, etc.? If you're doing a basic file server between a couple people, honestly, you can do it off a Raspberry Pi. They don't need much for processing power to do that. But if you need to run a file server with multiple people accessing it all at the same time and they're working on large video files, a Raspberry Pi won't cut it. So it does depend on exactly what you're doing. But we're in a home lab, so you can build what you need sort of as you need it. You don't need to engineer that right off the hop. I sort of summarize here, multiple services need more RAM and CPU cores, the same as the workstation, the computer that you're on, if you're running them all concurrently. So Raspberry Pi, just a few details on each of these things. Fun to tinker with. If you're into electronics, they're great because you can work on all these different pins, and you can control them, so you can do a lot of different things and experiments and automation and whatnot just by controlling the output on these pins. So as much as I look at them as kind of a toy, they do have a practical purpose. I've got a bunch of these actually deployed at a company for, like I said, those smart displays. Will they run a virtual machine? Not really. The Raspberry Pi 5, you can probably do it. I haven't tried it, but not really recommended. There's something called clustering, so you can kind of start to solve some of these performance problems through what's called clustering, but I wouldn't rely on it. Are they a cheap option? Not really, because you buy a Raspberry Pi and you get the board, you get the electronics board in the box. Then you got to go and buy a case. And then you got to go and buy the cables. And then you got to buy a power supply. Sometimes you can buy a kit that's got it all together, but they're not necessarily going to come in a whole lot cheaper than our next option, which is a mini PC. So these things a little bit bigger than kind of how it's depicted here. Maybe twice the size of what this thing is, a little bit thicker, a little bit bigger around. I've got one sitting behind my computer here. I can't pull it out right now to show you, but I like these things. They're small, but expandable. You probably do 64 gigs or more of RAM in them. Storage, you've got room for 1 or 2 NVMe storage slots. The one I got behind me has dual RAM slots. It has a single NVMe slot, and it's got a single SATA drive slot. So I've got 48 gigs of RAM in it. I've got a single boot drive with 512 gigs of storage on this NVMe slot, and then I got a 4 terabyte SSD drive on this SATA slot. So like I said, they're expandable, they're nice and small, fairly reasonably priced. The one I got was, I think it lists for about $500. Got it on Amazon on one of their flash sales for $300 and change sort of thing. Low power, cost less to operate obviously on the power bill, and they're not going to heat your house, which is, in the summertime, it's a perk. I did mention a little bit of limited expansion on them, but as we touched on in Raspberry Pi, you can do what's called clustering. So we can actually take 2 of these and essentially join them together. There's software that can basically handle those. So then they work as a single system. You'll get scalability if you need the extra storage. Processors kind of all work together, and they offload and balance what's going on between them. So like I said, you can do that with anything, but mini PCs are kind of fun in that sense because you might hit some of those limits and be kind of forced to expand and do that. Whereas with some of the other machines, well, you might just bump the processor, or you might swap out the hard drive or add a new hard drive. Clustering is kind of a fun way to play. So you get a little bit of limitations, but ways around it. So laptops, they work great. Limited expansion for both RAM and storage. A lot of laptops nowadays have soldered on RAM, so you can't change it or you can't upgrade it. So very limited in that sense. You might not get more than one drive in there. Macs especially, it's all a soldered single piece sort of system, so you can't expand the storage inside. So there's limitations to that. Desktops, we get into these mini tower units. Lots of fun to work with. You got lots of space. Plug in multiple drives in there to expand. Start with 1 and add 5 later on. You can plug in graphics cards. With virtual machines, you can actually pass through those graphic cards to your virtual machines. If you're building a file server, your price per storage bay is the lowest with one of these. So if you compared that to the Synology, let's just say for round numbers, that Synology cost $1,000. There was 4 drive bays in it right off the start. So you take your 1,000 divided by 4, whereas if you got something like this, you know, you might have 5 drive bays here. There might be a couple more hidden down here. You might be able to attach one up in the top. There might be a couple of slots on the back side of the board. So your price per drive bay to expand these things is a whole lot cheaper. Rack mounts. These are your big servers that a lot of people probably sort of have pictured in their mind. The picture you see here is actually a little bit more than a server. It's just ChatGPT coming up with some creative designs, but this thing you see pictured here is actually got sort of a couple of disk shelves. The middle of the picture, there's a bunch of spots where you would typically have drives. The bottom would all be drives. So those are called disk shelves, and they plug into the server itself. But these big things, they've probably got a couple of backup power supplies in them, lots of fans. They're heavy, lots of heat coming off of them, lots of noise. You can sound like a jet engine screaming at you in the middle of the night. So I just say here, just don't do it. As much as I'm tempted to have one or two of these things, I just don't do it. Mini PCs, this is my current favorite right now, but it does come down to what you're going to do with a home lab. For us in this cybersecurity field, if you went out and bought one of these things, I think you would be happy. You've got some storage, you've got some speed, you can set up lots of virtual machines on it, plug it in, and away you go. So like I say, your home lab is about growing with your needs and your interests. It's a lab. You're not designing a server and a network for a 10,000 employee company that you need to have perfect right off the start. It's a lab. It's an experiment in progress. Like I say, what I consider one of the best options right now. Expandable enough. It does have some limitations though that are kind of a perk. So you're going to learn about clustering. And you have budget-friendly options. Like I said, the one I've got, I can easily run 6 virtual machines that are fairly well configured all at once, plus the host operating system, plus it's running as a file server for me in this house, plus it keeps all that in sync with Calgary all at the same time. And I don't have any issues with that. It performs great. $327 is what it cost me, I think, roughly. Homework. So we're kind of wrapping up here. Again, completely optional. Do not let this stuff interfere with your Lighthouse studies, but good to know stuff, especially if you want to get into that network course and just for general knowledge. So research NAS, Network Attached Storage, and DAS, DAS. Figure out what DAS might mean in the terms of networks and storage. Why would you choose one over the other? Research a little bit about RAID. You don't have to get too crazy and memorize your different RAID levels, but just could be some interesting Googling here about RAID and what it is. And also understand that RAID is not a backup when you do get reading about RAID. Do not think because that Synology that I have pictured with 4 disks and how I was saying it can work together and replicate the data for sort of a fail-safe process. It's not a backup. If that machine dies, the board on it dies, then the data's there if the board was to die, but it goes off and it's done. But you want to understand backup levels as well. 3-2-1 is the common sort of thing about backup. Have 3 copies of your backup, 2 different mediums and one that's off-site sort of thing. So learn a little bit about RAID and backups. And of course, develop a basic understanding of your existing home network up to and including your router. Like I said, get into that router. Do not change anything, but just understand what's going on in there to a certain degree. See what's connected. See what your log files are showing. See if anybody's been trying to connect to your device. Inventory and map your devices. See what you've got for MAC addresses and what type of device it is. Are your IPs static or dynamic? A little bit more. Do a little bit more digging into that router. Can you set static IPs? That'll be somewhat important. Not critical, but somewhat important once we deal with setting up actual servers. Perform that audit on your router log files. Good practice for our course here. Can you complete that project we talked about, plugging in a drive and creating a NAS device on your network? Create a network topology or an inventory of your devices. That's just good to have. And did you study and learn a little bit about what this PoE is from your cabling section? So that's where I've left off with part one. So yeah, we've been at it for just over an hour. I don't want to get too carried away and into some next sections. But anybody got any questions, or what were you hoping to get out of this so far?
I'll start with just one question from before. When you're looking at the new PCs, I'm guessing it's more like a B-Link or something like
Yeah,
that.
yeah.
I'm just wondering, have you tried playing with those small compact form factors towers versus those the mini PCs?
I haven't yet. No, no.
Okay, all right. Or just wondering if there's a reason for the preference between the two different small.
Yeah. No, I haven't at all. I like the idea of the mini PC. It kind of bridges between that bigger box. Like I've got the Synology, I've got the expansion bay with it, and external drives attached to it. So it kind of the mini PC kind of bridges that gap between a Pi and something bigger. Plus, for what I was doing here, I wanted all solid state storage. So
Right, right.
so the mini kind of fits the bill. It was easier on the wallet because I got less of a UPS to attach to it. The whole sort of deal.
Okay. Yeah, that makes sense. You pulled the trigger on those flash sales on Amazon.
Yeah.
I was watching it for a little bit, but I didn't do it.
Yeah.
But yeah, perfect. Thanks.
Anybody else got anything, or was everybody hoping to build a server today, or what? What were we hoping to do?
No, I think for me, it was just learning the basics and kind of, now I've got something to work with. I mean, I kind of knew I needed to figure out my router and my home network and map that out and how many devices that I have, because if I can't protect that, then what am I gonna do? Somebody's hiring me. I need to know, how to figure all that stuff. And I think this gives me a start as to things to think about and how to get into it and play a little bit and
Yeah.
learn. So this is great. Thank you.
Okay. Yeah. No problem. And yeah, like I do have multiple parts here. I've got a bunch of extra slides. I don't really want to get into it today because it will take probably another hour. But then we go into basically building, talking more about virtual machines from a desktop usage, and also including server virtual machines. So
And I don't know about anybody else. I didn't think a server was what I wanted to do today. I just wanted to figure out how I could, even my old PC that's just sitting here and it's dead, like how can I'm going to take that apart and see what I can use, like the power, the power unit's still good. And I don't know about the graphics card. That's not really important if it's a home lab. And I just found, like I'm looking even on Best Buy, there's like a processor, an i9 that's opened, and it's like $300. That's a pretty good deal.
Yeah.
So that would be more than enough, right?
Oh yeah,
I mean,
yeah. And now that's assuming it works in what you've got for a machine. It may not.
Yeah.
It may not even physically fit. You need to make sure your motherboard is compatible. Yeah.
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 No, I'll probably have to buy a new motherboard. I bought all this RAM for it to upgrade it before it died. So I'm going to check to see if that RAM will still work and if I can find something that can still, because I don't want to just throw it out. I bought it on Amazon and it's more than 32. I think it's 32 gigabytes plus it's got a little bit more. So that was already in there. So I don't want to throw that out. So I'm going to try to see what I can still salvage and use. But even that gives me a start from where to go. So.
Yeah. And you may want to diagnose where it died. Is it the power supply? Pull the power supply out, put a new one in for $60 or $70. Is it the drive, the storage? Pull out.
It's a really old computer, and I got the blue screen of death.
Well, so at least it's coming on. It goes past boot up. You could put a Linux. You could create a Linux boot disk and pop that in there, wipe it from Windows, right. and now you've got a Linux machine, and then turn that into a server.
Right.
So
so maybe I don't even need to buy that stuff. But it would be fun to rebuild it.
Yeah.
Because
Oh,
I
for
know
sure.
it's old. It's pretty old.
Yeah.
It's an HP Envy. It's it's been like more than 10, 11 years. But I just thought, why not see what works and what I can still use. So
Mm-hmm. Yeah. But yeah, no, it sounds like you've got a working machine. It just, yeah, you can certainly upgrade and do more, or you can play with what you've got, or both essentially. So
Yeah,
how?
this good general introduction. I just wanted to know the lay of the land, and
Mm-hmm.
thank you. Very helpful. I'm definitely gonna do my homework.
Yeah, yeah, no, that's great. And so yeah, like I say, I wanted to. A lot of people will talk about Homelabs and they'll go right into, okay, buy this box, buy that box, install this on it, install that on it, and there's your home lab. Well, there's a little bit more to it, because a home lab is more about just a single box, a single piece of equipment. You need to understand, well, like I say, sort of understand what you've got for your computer, because a lot of people just they don't pay attention to that. They plug in their Wi-Fi password, their username and password, and away they go. People don't know what they got for storage space on their device. They don't know about that router that their ISP plugged in. But that's all part of networking and understanding what's going on. And then as we progress with this, if we build a server, let's say next week, how's that going to interface with your router? How's that going to interface with the other devices on your network as well? And then that'll also come into play with understanding our work in Lighthouse. When we're talking about virtual networks, we've got our VMware or our VirtualBox, and we've got our NAT networks, or in the case of Mac, when they just kind of mysteriously stopped giving the instructions for setting up the NAT networks. It'll give you a bit of an understanding about that, and especially as we get into that week 10 stuff, with forensics, we're analyzing malware. We're not really analyzing malware, but we're analyzing a machine that had malware on it and does have malware on it. But at that point, you want to understand how the network is functioning, because you don't want to infect other machines on that network, whether it's virtual, or you don't want it to infect outside of that virtual network and into your own computer. Our Week 10 project won't, I'm assured, and I tried to get it to do that the other day. As much as I tried poking and prodding at this thing, it wouldn't infect anything else, so that's at least a good sign. But you need to have that understanding of networking. I think that's why Stephen, Mr. Franks there, likes to suggest and recommend that we maybe look at Network Plus certifications as well as our Security Plus and other certifications on top of that. So just good knowledge to have. So, and again, the backbone of what we're doing for a home lab. Anything else, or is everybody good? Or have I utterly confused everybody?
No, I think this was really good. I'm actually glad it wasn't straight into building servers. It's like easing into it. I'm really excited to get digging and figure out what's going on with my router and take that in there.
Good. Like I say, just don't play with any settings right yet.
No.
Yeah, for me as well, I never thought first, probably a year ago, I never thought I'll be doing this course. For me, it's educational first to understand what is a home lab and how much I can do and how I would be using it. It's first it's information for me.
Yeah.
And
Yeah.
slowly, probably I can definitely build something, but it's just knowledge first for me.
Yeah. Yeah.
Thank you,
Exactly.
Anthony.
Yeah. You're welcome. Is everybody else good then? If we call it a day there, we're all good, and then I'll continue. I got a few more slides for the next part, and that'll bring us into a little bit more in depth about working with our virtual machines, because what Lighthouse has provided us are called virtual machine images. They're basically pre-built, and so the next step, what I want to get into, is actually not using those images, we're going to basically create a virtual machine from scratch, more or less, from the operating system itself. We'll install operating systems into a virtual environment and then actually turn one of those virtual machines into a little bit of a server, and get you an understanding of that. That way, like for you, for instance, Kat, when you rebuild a machine, you'll have a little bit more of an understanding of installing from scratch. Although you mentioned you built a gaming machine there. So you probably know how to do that, but for anybody else, that'll also show you how to install operating systems from scratch instead of just using a pre-built image like Lighthouse gave us. So that's where I want to take it next time, and hopefully next week, or next weekend, probably around the same time if that works for everybody. But I'll let you all know once I throw a few finishing touches on some slides and add a little bit more content and get my own system ready to show you with that. So.
Okay, that's very cool. Thank you so much, Ernie.
No
Thanks,
problem.
everybody.
But yeah, thanks everybody for coming out. So any questions last minute, shoot them my way and see what I can fill in for you.
Sure, Ronnie. Thanks so much.
No problem.
Thank you, Eddie.
Thank you.
Thanks.
Oh, one last question, actually, Artie.
For sure.
So, I know the cardinal rule is the for backups is 3-2-1, and the RAID is not backup. So I do have Synology. So
Yeah.
I'm just wondering, how do you back up your Synology? Is that through another Synology, and is that the application that's already pre-built through Synology that you use as backup to back up your remote one? If that makes sense.
Yeah, makes sense, but no, I don't do it that way. I've got actual multiple steps. So I've got another offsite unraid machine, so it copies through. How do I even have that configured? I'm trying to grasp an application name. I can't think of what it is.
No worries.
But it's an unraid machine on the virtual machine. It runs this program. Sync back free, I want to say. If you're looking for names, I think that's what it is anyway. But it just reaches out to my Synology and pulls in the important data. I also have the Synology itself. I'm not sure if you've looked into yours, but it can actually sync with cloud services. So I actually have it running two different ways with two different Google storage, two different Google accounts. So my main Google account, it pulls the data in to back up from Google onto the Synology, but then the Synology is also sending back out to another Google Cloud account to back everything up that's important. So.
Okay.
So I've got an offsite on hard disk, and then I've got cloud backups running as well.
Okay. So, oh, that makes sense. Because I was wondering if you're using Backblaze, because their particular pricing system is a little somewhat confusing for new people, because they have the B2 within their personal and all that stuff.
Yeah, I looked into that as well. I never went that way. So.
Yeah. And I had another question. Unfortunately, I forgot it right now. So it'll come back to me in a couple seconds.
No worries. And yeah, I'm not saying I'm an expert in all this either. So anybody who's got any extra input, feel free to throw it out there.
So I've been in the research stage for a little while. Building a home lab was something that I wanted to do for quite a long time. So I have a lot of like materials or just like information from the web that I've curated to kind of help build up my plan. But have you tried out Proxmox or TrueNAS, and why have you stuck with Unraid? I guess in this case, because it looks like that seems to be the main platform.
Yeah. As soon as I get back to Calgary, I do want to do up a machine that's strictly Proxmox. I haven't done it here just because I don't have. Well, I shouldn't say I don't have the resources. I technically do. I just don't. I don't want to go and buy a bunch of switch. Well, an extra switch and this and that just to set up a dedicated Proxmox machine and have it hardwired in and whatnot. It was kind of purpose built for where I'm at right now. So like I say, it's on the list of things to do when I'm back in Calgary is to work with Proxmox and just compare it to Unraid. I used Unraid. I forget when I first started playing with Unraid, and I really liked it because I was more into file servers, and I needed the storage and that flexibility. So that's why I went with Unraid. Its virtualization, though, I do find quite well. It's kind of finicky, so that's why I want to do a Proxmox one just to compare. But Unraid's virtualization does work great. Like I've got on my one machine, I've got a Windows VM passing through a graphics card. I forget the specs on the card. It used to be a good one. But that passes through, the keyboard, the mouse, all that passes through, audio passes through, and it's, for the time when I did set it up with the graphics card, it was running some pretty decent games pretty well. It was what they call the bare metal or near bare metal experience. Not perfect. If I wiped that, or not even wiped it, but just swapped out the drive, let's say, and ran it straight, a bare bones Windows install, you could see the difference. Don't get me wrong. But the virtualization was good enough that I had no issues with it. I'm not a hardcore gamer or anything like that, but it worked quite well. So I did that with the Windows one, and I had a developer. I do have a developer Linux system set up on it as well. So I can switch at any time between the two VMs and have that near bare metal experience with Unraid. So I just never felt the need to go to something else.
Okay.
And the file server was, running, and it runs flawlessly more or less. So
Yeah. All right, fair enough. That's one of the points where I'm trying to figure out if I want to do virtualization or just for VMs, which way do I go? And you just jogged up a couple of things for the mini PC. Are you running a program off of that, kind of like how we are with VM Fusion for the Mac, or as an app to do virtual machines, or you're booting it up in a different way on the mini PC?
Yeah, so the mini PC that I have here, it boots into Linux Mint, and on there I've got VirtualBox. So I've got, I don't do much with the main operating system of Mint, just because I've got the MacBook right here. I got a Windows. I'm surrounded by Windows machines here, so I don't do a lot with it. But when I need, I do a lot of like our lab work with the virtual machines off of it, so I can remote into it and do that, or I'll just pull it up on a screen. I do have it on a screen up on top of my Mac display here. And then I just switch keyboards to it. So I'll use it mostly for the virtual machines. And then in the background on the Linux Mint operating system itself, it's set up as a Samba file server for the network here. And then it's also syncing back to Calgary on the operating system itself. So if that answers.
No, it definitely answers it.
Okay.
I'm trying to figure out if I can just start off from the beginning, just have the small PC as my play area.
Yeah.
Because I might be getting to, just like any home lab thing, you start thinking more grandeur, thoughts and
Yes.
what you can build out. So I want to have a play area. That's the only thing, and it seems like the mini PCs might be the best way to go.
Mm-hmm.
But then I was thinking, well, Unraid, you can just buy whatever those system enclosures, and then put in a couple 3.5 hard drives, and maybe you can do Unraid through there.
Yeah.
And then maybe virtual VMs through that. So that's where I'm trying to figure out which direction to go. But from the sounds of it, for the purposes of what we're doing, and perhaps afterwards, the small format PC might be a great budget and more friendlier version to go about playing around.
It could be. And then a potential option too is just have an extra NVMe drive. Whether you want to pop the thing open every once in a while, like if you mess something up, like have sort of a production or sort of a backup operating system almost, so that if you do mess something up, you can just swap back to it. Or that's where the virtualization is nice. And honestly, with this one that I've got, like it performs quite well. The virtual machines in it. So, I'll give, like I say, I think it's got 48 gigs of RAM right now. So I'll give different machines, 8 or 16 gigs of RAM if I'm doing something a little more intensive on one, just to make it perform, and throw a few extra cores at it. And then I can always tweak them down differently if I'm doing something different. So I think it works great, honestly, for what I'm doing. So.
Oh, it's great. It just gave me back onto the. I shelved this idea a little bit back, so it was more like Raspberry Pi, mini PC, a Lenovo Think, whatever small form factor.
Yep.
And I was like, all right, which way do I go? But now I mean, I've never met anybody in my circles yet who's been playing around with the B-Link or one of those other mini PCs. So it's good to hear at least some real feedback, especially since we're in the same. Do similar things.
Yeah.
To a certain extent.
Yeah. No, that's why I like it now. I wouldn't get like I said in the slides there, unless you're really getting into electronics. The Raspberry Pis are fun in that sense. I haven't gotten into the electronics part of it. I used to be an electronics tech in the military, and I've played around with electronics since I was a kid, pretty much. So I want to, but it's just one of those on the to-do list, So that's why, one of the reasons why I've got them, but also, like I say, because I've got clients that I've done custom software for on them, so I need to sort of just keep in mind for performance and bug testing and whatnot. So that's why I've got them, but I wouldn't use them for a home server environment for what I do. I just don't see them performing. So.
Yeah. Some of my friends have advised me to use a Raspberry Pi as kind of like a Pi hole, so you can start using it for like AdGuard and all those things.
Yeah.
But not for a full-fledged anything else. So
exactly.
That use case for me was like, all right, I'll move to something else.
Yeah, exactly. So.
I guess last thing, which model B-Link did you end up getting? Because I am actually going back in my history for like things I've saved, and there seems to be a lot more models than I recall. Is it the?
Let me just take a quick look here.
Here's the other thing, is that there's been issues with Intel processors. I'm not sure, is it the 13th or 14th generation, or is it the 12th or 13th? But I'm wondering, have you had any issues if yours is an Intel processor in terms of overheating, because you have monitoring for the temperatures, I'm guessing, and all that stuff? Have you noticed anything?
No, I've got the Ryzen 7.
All right, fair enough.
Now, actually, because I was going to say I've got a laptop that, despite 32 gigs of RAM and being brand new, just doesn't perform very well, but it's actually a Ryzen 7 as well. So there's the one that I've got there, linked in chat. Ryzen 7, 8 cores, 16 threads. Came with 16 gigs of RAM and 500 gig NVMe, but I've upgraded the RAM, and then it had the slot, the SATA slot in there, so that was nice. So.
Okay. And there is room on those, because I haven't played with these small forms. I've had those very miniature towers that I've built in the past, where the motherboard was had to be a certain size. I've never opened one, but is there a lot of different slots that's available to upgrade, or is it just really like one or two? Because it's how small it is.
Yeah, it's RAM and RAM and storage space. That's it. So this one, 2 slots for RAM. It's got the NVMe slot, and it's got the SATA slot, and that was it. I see a lot of other ones. They're single stick for RAM, but they'll give you 2 NVMe slots and no SATA slots. So it's a little bit of give and take. So it like I say, in the slides, it kind of comes down to what you want. If you wanted to run a media server and you're going to download a bunch of shows and everything else, that's going to chew up your space pretty quick. And spinning hard drives are fine for that. But for me here, like I say, I built this because it's a lot of just data with my development environment and whatnot going on. So I wanted the speed, just quick access back and forth, and I'm fine with SSD for that. For limited space of SSDs for that, and and then it keeps things in sync back with the Synology for spinning hard drives. So for what I'm doing, that part works well. For what I'm doing in Calgary, where I needed the space because of media clients with their data. Spinning hard drives were fine, so I needed the towers for that to plug in the spinning drives. So
Fair enough. Fair enough. Well, it's very helpful. Appreciate it.
yeah,
I don't have any other questions really.
Sure.
I'm sure like once I go down again this rabbit hole, because it's opened up just a little bit.
yeah.
It'll be fun again. And I have a couple of questions and I'll poke and prod you.
Yeah, no, for sure, anytime. Like I say, I'm no expert on any of this. I just play around, and all of a sudden, a little simple box turns into a whole nest of gadgets. So
Yeah. How I got into it was essentially I was trying to figure out how to save, similar to you, without having subscriptions for media.
Mhm.
Netflix, Disney.
Yeah.
I wanted to do that, and then as well as have my own similarity of Google Drive, so I can host my own photos and stuff.
Yeah.
So I was able to do that in Synology. Now it's
Yeah.
like, oh, I can have VMs. What's the next thing?
Yeah,
Now I
yeah.
can figure that out. And
Yeah.
It's just
Ex-
keeps going.
Exactly. Yeah, and I don't know if you've tried VMs on it or not, but if it's a graphical VM, it's not the greatest, but
Yeah, it's I use my tower.
Yeah.
It's not the best on the NAS, but
Yeah.
I mean, at least it's there. The option's there, so it's always nice.
Yes, yeah, exactly.
But, at this point, I appreciate it. Thank you so much.
Oh, no problem. Thanks for coming out.
I guess if anyone else has any questions.
Okay.
Regarding media server, is it just like a plug and play thing with the router? Just plug in the external hard drive and read it or whatever's on export it to like the rest of the network be accessible?
Yeah, sorry, for your like your USB drive going into your router? Is that what you're?
It's I forget what kind of drive it is, but it's like the bigger one, the one with the spinning disc.
Yeah, yep.
So we just plug that into the router and accept it as an external hard drive, and it'll be considered a media server.
Yeah, the router itself would basically be functioning as the media server in that case.
Okay.
And that's
there's no config you have to do.
no, sorry, did you say earlier you got Bell as well or no?
Yeah, Bell.
Yeah, you should be able to plug in if there's stuff on that drive. It should show up. Actually, I was going to look it up and see what it shows up as mine, but I don't have a drive plugged in right now. It should show up in there. You may have to go to that IP address though on your computer or whatnot, but it may very well show up as a media device and show you what's on there for media.
Okay, I'll take her around with that.
Okay.
I was looking at the system. Yeah, it's interesting stuff.
Yeah.
I played around with it before, but I never noticed the system logs before.
Mm.
How it just shows and all that. Interesting stuff. This is
Yeah.
exactly what I actually wanted to get at. Too.
Oh, that's good.
It's like, thank you for that.
Yeah, no problem.
One final question.
Yeah.
I'm with Bell as well,
Yeah.
and I've played with that router interface. If you find some device with a MAC address that you're not familiar with, What do you do?
There's Mac address lookups that you can get into just to try and get an understanding of what that device might be. So that's probably a good place to start. I guess
That's
on,
not within the dashboard, huh?
sorry, what's that?
That's not within the Bell dashboard. That's like
Yeah, that would be totally separate.
okay.
I couldn't even tell you off the top of my head some different places to look up. I know I was doing that back in our early lab days, though, when we were first doing the ARP scans and whatnot.
Yeah.
Because on Windows, I think there was it was showing a couple of extra devices that they suggested that we ignore. But of course, I'm poking and looking to see what they are and whatnot. So I know I came across a couple that would you could plug in the MAC address and it'll tell you what they are to a certain degree. So that would sort of be a good place to look. Now that being said, if you're looking at a log file and it happens once, once every few days or weeks or whatever, probably not a
Yeah.
big deal. But if you got a rapid succession of somebody trying to of an unknown device and wrong passwords, that might be something to look at. And maybe you have to hide your SSID, because somebody's discovered it, change it, and then hide it, So
Yeah, that's what I'm worried about. So now that you brought that up under the dashboard and the logs, I actually didn't know the logs were there. So that's actually a good thing. So
Yeah.
that's another thing I'm going off for today. So that's great. Well, I appreciate it. Well, I guess hopefully you let us know if there's any way we can help, or I can help for next time, because I'm sure it's fun to build out and
yeah,
explain these things.
Yeah.
But
yeah. No, I'm gonna post a link to the slides here, and then some software and gadgets that we've sort of talked about or skimmed through today, and then that way, sure, if there's something that you see something in the slides coming up and you want to fill in some blanks, then sure, we can do something like that. So more than happy to have some contributors.
that sounds great. Well, again, much appreciated. All right. Have a great weekend, everybody.
All right, thanks, you too.
Take care.
Take care.
Anybody else got anything, or are we all good?
For now, I'm good, Ernie. I do have, I do have the information, so I'll be reading about it. Thank you.
Okay, you're welcome. Good. Sorry, Chanel?
Can you hear me?
Barely.
Yeah, it's very low.
Yeah.
How about this?
Still pretty low. There,
Right here?
there you are.
Okay. No, I just wanted to thank you. Like, I can't imagine how much work you put into this, and like I've learned a lot. I feel like everyone's learned a lot. I did have like a bit of a question. It might fit better with next week. I know Stephen Frank mentioned that the GNS3 is his
Yep.
go-to lab. I was curious if you had a second perspective to that.
So GNS3 is kind of a network simulator, which there's nothing wrong with that, and nothing wrong with his suggestion. Obviously, he's got more experience with it than I do. I haven't really played around very much at all with it, but we have to get to the point of using GNS3. So I mean, maybe you're there. I don't know, but that's where I wanted to go next week. Was let's install an operating system, and then we've got the base that we can build on top of that. So we can create a file server. We can install GNS3 on that. Another virtual machine manager. So that's sort of the direction that I was leaning towards. But yeah, GNS3. If he's recommending it, and yes, I've been on a few chats with him, and he certainly does, and he talks highly about it. I think it would be great, but at the same time, we need the building blocks to put that on top of, to install that on. So that's kind of my direction.
Yeah, that sounds good.
Yeah.
Yeah, I don't have any more questions. Just thank you
Sure.
as always.
Yeah,
Very
no,
helpful.
thanks for attending.
Well, yeah, see you next week. And
See
see
ya.
you people.
Yep.
Well, thank you, Eddie. Yeah, like I was just hanging around to hear other people questions, but yeah.
For sure. Yeah, no, that's great. Thanks for attending. Thanks for poking me a little bit to get going with this. So hopefully you got something out of it. And like I say, I didn't want to throw everybody into building a server or something on day one. I wanted to sort of start with some basics and go from there. So
Yeah, it's a lot. And like, I do have a very quick question just now, like while speaking, you did mention about with cat, I believe, like regarding a laptop, if it's not working, you can completely format it and then install Linux. That's what you suggested, right? Rodney?
yeah. As long as it turns on, as long as the hardware works, yeah, you can burn a Linux installation medium to a USB stick. Plug that in, boot it up off of there, and then install. And so basically, I'm going to get into that. Like I say, hopefully the next weekend. I just got to put some finishing touches on the slide, and I'll basically be talking about that. So it's how to install an operating system from scratch. So.
Sure, because like when she explained that scenario, I also had a laptop, but recently I got that blue screen of death, and I was not able to do anything. But it's a old laptop, so I thought, okay, it's done. But but today I got something new. I could literally play with it
Yeah.
to see like if I can install the Linux and then experiment few things. Yeah, that gives me idea. And also regarding the bell, I tried to log into that 192 like regarding that one,
Mhm.
and it shows me error. Early. Does it happen? Like is there some issue with my settings?
Sorry, it shows you which.
Uh, I tried to connect to the Dell. Sorry, like to the Bell admin thing, which
Yep.
is 192.168, right? And it gives me an error. It says that it can't connect or the connection fails. But, so it was a pretty interesting for me. But I was gonna look more about it. But do you know anything
So
regarding that issue?
yeah, it just may be a different subnet. So if
Oh, okay.
like if you go to like you're on a Windows machine, right?
Yes, yeah, I'm on a Windows machine.
So if you opened your file, well, it might not even show you there. You might honestly have to do like an ARP scan for your subnet
Okay.
just to see.
Okay.
Well, no, actually,
Okay.
sorry, you don't even need to do that. What am I thinking here? If you just open your command prompt, your
Command
terminal,
Yeah,
and
yeah,
you find the IP address of your network right now. So Windows, what is that? IP config.
Yes, IP config. I'm just typing it. Let's see.
Yeah.
IP config. So it gives me IPv4 addresses or 2.23. So that's what it shows it.
So like 192.168.2.3.
Yes, 2.23.
Okay. So yeah, I'd be surprised that 192.168.2.1 doesn't work then for your router if you're on Bell.
So it's like a default gateway. So when I see the wireless LAN adapter, that's the one I'm looking at.
Mhm.
But is there something else that I should be looking? No. Yeah. So when I look at this, my IPv4 address is
Yeah.
Ethernet. Okay. So it
Yeah.
shows that 192.168.2.1. Then I don't know why is it not showing up there.
So do you have a default gateway showing underneath that?
Yes, it's showing. Yeah, your default gateway is 192.168.2.1. Let me try it again. Yeah, it is. When I try to log in, it says this site can't be reached. Yeah, that's interesting.
That is interesting. You might have to check like physically on your router to see if there's a sticker or something that shows you the login IP address. It's
Okay.
it's
Sure.
it's possible also you could maybe try the 192.168.2. like 254. Sometimes they'll stick them at the end of the IP range.
Okay, then I'm gonna look it up. Yeah, yeah, sure, different. I remember doing it long time ago when I was with Rogers. Like the same thing. So it's like admin password and admin username, but never tried with the bell. But today I wanted to give it a try when you explained it.
Yeah.
And then I was having this issue. So
Okay.
I'm gonna look it up in the back of the router. So it's a normal white one.
Yeah, there
So
might be a sticker on there. Even if you're like on the call right now, you might want to try like .2.254 because that's what my TELUS one is back in Calgary. Well, it's actually 192.168.1.254, but they stick it at the end of the IP address range. So usually it's the first or the last.
I'm trying the 192.168.1.254.
Or 2.2.5.
Okay.
Yeah. Yeah, just my TELUS one is on the .1.254.
No, it's
No.
saying that no. So like I'm gonna look it
Okay.
up and then I'm
Yeah.
gonna see that
Yeah,
what does
yeah,
it show.
yeah, for sure. So,
Sure. Yeah. Thank you very much, Andy.
all right, no problem.
So have a nice evening.
All right,
Take
you
care.
you as well. Talk to you later.
Thank you. Bye.
All right, bye.